3.0.0 Wireways and other specialty raceways. After completing this module, you'll be able to explain how to select and install wireways and other specialty raceways, identify the types of raceways and their components, describe how to install wireway supports, describe how to install specialty raceways. A wireway is a sheet metal trough with a hinged screw-on removable cover. Like other types of raceways, wireways are used for housing electric and wires and cables. Here, a trough is a long, narrow box used to house electrical connections that can be exposed to the environment. And as it said, it usually has a hinged cover that can be removed. As you can see in Figure 52, a wide range of fittings is required for connecting wireways to one another and to fixtures such as switchboards, power panels, and conduit. The NAC has many articles and sections covering wireways, other specialty raceways, and their fittings. So here's a wireway. And basically it's this 4x4 trough with a hinged cover that connects all of these different power panel, motor disconnect, heaters. You can bring conduit out of them, drop straight down into the device that you're wiring. 3.1.0 Types of wireways and their components. Rectangular duct-type wireways come as either hinged-covered or screw-covered troughs. They're available in a variety of lengths so you can avoid cutting. Rain-tight troughs are used in environments where moisture is not permitted within the raceway. However, a rain-tight trough should never be confused with the rain-type lay-in wireway, which has a hinged cover. Figure 53 shows rain-tight trough with a removable side cover. And to be rain-tight, you notice that the top or lid has a lip that completely covers this cover that goes up in the side here. It has to be up underneath so that it's covered from all sides, and then this cover itself has sides on it that cover. They overlap this lip on each side of the opening. That keeps any water from getting inside of the trough. Wireway troughs are exposed when first installed. Whenever possible, they're mounted on ceilings or walls, although they may sometimes be suspended from ceilings. Note that in Figure 54, the trough has knockouts similar to those found on junction boxes. After the wireway system's been installed, branch circuits are brought from the distribution panels using conduit. Conduit is joined to the wireway at the most convenient knockout possible. So they have concentric knockouts that can be punched out whenever you need them. It has end caps that you can put on, or you can put a U connector and continue the trough, put another section beside it. Here's the trough cover that is screwed on. Let's see, it says, when assembling wireways, always place the head of the bolt on the inside of the nut on the outside so the conductors will not be resting against a sharp edge. It's usually best to assemble sections of the wireway system on the floor and then raise the section into position. An exploded view of a section of wireway is shown in Figure 55. Both the wireway fittings and the duct come with screw-on hinged or snap-on covers to permit conductors to be laid or pulled into the trough. There's 55. There's your expanded view. These are the covers that go on. The NEC specifies that wireways may be used only for exposed work. Therefore, they cannot be used in underfloor installations. If they're used for outdoor work, they must be of an approved rain-tight construction. It's important to note that wireways must not be installed where they are subject to severe physical damage, corrosive vapors, or hazardous locations. 3.1.1 Exploring wireway regulations. To properly and safely install wireways, you must be familiar with the applicable NEC regulations. NEC Article 376 covers metal raceways or wireways. Article 378 covers non-metallic wireways. Here's a highlight. It says, as listed in NEC section 376.22a, the sum of the cross-sectional area of all contained conductors and cables at any cross-section of a wireway shall not exceed 20% of the interior cross-sectional area of the wireway. So we can't just cram these things, tight as much wire as we can fit on them. We're limited to 20% fill. So metal wireways is Article 376, and non-metallic wireways is 378. The grading factor in NEC Table 310.15C1 shall be applied to wireways only where the number of current carrying conductors exceeds 30, including neutral conductors classified as current carrying under the provisions of NEC Section 310.15E. Conductors for signaling or controller conductors between a motor and its starter used only for starting duty shall not be considered current carrying conductors. So more than 3 current carrying conductors, NEC Table 310.15C1, and neutral conductor 310.15CE. Here's a highlight. NEC section 376.56a notes that conductors together with splices and taps must not fill the wireway to more than 75% of its cross-sectional area. So they told us that we were limited to 20% fill, but we are allowed to make splices and taps, and we cannot have a cross-sectional area more than 75% filled. No conductor larger than that for which the wireway was designed shall be installed in any raceway. NEC section 376.23a requires that the dimensions in table 312.6a be applied where insulated conductors are deflected in a wireway. That's the minimum wire bending space at terminals. Auxiliary gutters are covered in NEC Article 366 as defined in Article 100. An auxiliary metal gutter is a wireway intended to add wiring to wiring space at switchboards, meters, and other distribution locations. Auxiliary gutter. Even though the component parts of wireways and auxiliary gutters are identical, you should be familiar with the differences in their use. Auxiliary gutters are used as part of a complete assembly of apparatus such as switchboards, distribution centers, and control equipment. However, an auxiliary gutter may only contain conductors or bus bars, even though it looks like a surface metal raceway, that may contain devices and equipment. Unlike auxiliary gutters, wireways represent a type of wiring because they're used to carry conductors between points located considerable distances apart. Allowable ampacities for insulated conductors and wireways and gutters are given in NEC tables 310.16 and 310.18. It should be noted that these tables are used for raceways in general. These NEC tables and their notes are often used to determine if the correct materials are on hand for an installation. They're also used to determine if it's possible to add conductors to an existing wireway or gutter. Ampacities of insulated conductors with not more than 3 current carrying conductors in a raceway, cable, or earth directly buried, 310.16. It says ampacities of insulated conductors with not more than 3 current carrying conductors in a raceway or cable at 40 degrees Celsius ambient temperature is 310.18. 30 degrees Celsius ambient temperature is 310.16. In many situations, it's necessary to make extensions from the wireways to wall receptacles and control devices. In these cases, NEC section 376.70 specifies that these extensions may be made using any wiring method present in Chapter 3 of the NEC. That includes a means for equipment grounding. Okay. And finally, as required by NEC section 376.120, wireways must be marked in such a way that their manufacturer's name or trademark is visible. 3.1.2 Wireway fittings and connectors. Many different types of fittings are available for wireways, especially for use in exposed dry locations. Connectors are used to join wireway sections and fittings. They slip inside the end of a wireway section and are held in place by small bolts and nuts. Alignment slots allow the connectors to be moved until it's flush with the inside surface of the wireway. After the connector is in position, it can be bolted to the wireway. This helps to ensure a strong, rigid connection. Connectors have a friction hinge that helps hold the wireway cover open when needed. End plates or closing plates are used to seal the ends of wireways. They're inserted into the end of the wireway and fastened by screws and bolts. End plates contain knockouts that conduit or cable may be extended from the wireway. So here's a knockout. T-fittings are used when a T connection is needed in a wireway system. A T connection is used where circuit conductors may branch in different directions. T-fittings cover and sides can be removed to access splices and taps. T-fittings are attached to other wireway sections using standard connections. So here's a T connection. And crosses, it's just four-way intersection. Elbows, here's an elbow. Telescopic or split fittings and adjustable length fittings that may be needed between two lengths of wireways. Split fittings are attached to standard lengths by screws and usually adjust from 1/2 to 11.5 inches. Slip fittings have a removable cover for installing wires and are similar in appearance to a nipple. Slip fittings are used where the needed length of wireway does not conform to a standard available length. Wireway supports 3.2.0. Horizontal wireways runs must be securely supported at each end and at intervals of no more than 5 feet. Individual lengths greater than 5 feet must be supported at each end or joint. These guidelines should be followed unless the wireways are listed for other support intervals. In no case shall the support distance be greater than 10 feet in accordance with NEC section 376.30A. If possible, wireways can be mounted directly to the surface. Otherwise, wireways are supported by hangers or brackets. In many cases, the wireway is supported from a ceiling beam or other structural member. In such installations, a suspended hanger may be used to support the wireway. Wireway is attached to or laid in the hanger. The hanger is suspended by a threaded rod. One end of the rod is attached to the hanger with a hex nut. The other end of the rod is attached to a beam clamp or anchor. Here's a bracket. You can mount them on a bracket. Standard hangers are made in 2 pieces. 2 pieces are combined in different ways to form different installation requirements. Wireway is attached to the hanger by bolts and nuts. A large wireway must be suspended. A wireway hanger may be used. A wireway hanger is made by suspending a piece of strut from a ceiling, beam, or other structural member. The strut is suspended by threaded rods and attached to beam clamps or other ceiling anchors as shown in figure 64. So here are the pieces of all thread, and then they put a piece of strut across, and that will suspend or support the wireway. 3.3.0 Specialty Raceways. Specialty raceways include enclosures such as surface metal and non-metallic raceways, underfloor raceways, and underground ducts. 3.3.1 Surface metal and non-metallic raceways. Surface metal raceways include special raceways designed to carry power and communications wiring to locations on the surface of ceilings or walls of building interiors. One use of surface metal raceways is to protect conductors that run to non-accessible outlets. You must install all these raceways in dry interior locations. NEC Article 386 covers the installation of surface metal raceways. NEC Article 388 covers the surface non-metallic raceways. NEC Tables 310, 16, and 18 and NEC Articles 386 and 388 are also list regulations for the number of conductors, the amperage, the allowable cross-sectional area fill of the conductors, and combination raceways. Know the code. It says ampacities of insulated conductors with not more than 3 current-carrying conductors in a raceway, cable, or earth, if it's a 30 degrees Celsius ambient temperature, which is about 86 degrees Fahrenheit. It's table 310.16. Ampacities of insulated conductors with not more than 3 current-carrying conductors in a raceway or cable with a 40 degrees Celsius ambient temperature. That's table 310.18. Surface metal and non-metallic raceways are divided into subgroups based on their intended purpose. These are 3 small surface raceways that you use primarily for extending power circuits from one point to another. Usually you only have one circuit in a surface metal raceway. We call this wire mold, and they're saying that it comes in metallic or non-metallic types. You have a 1/2 inch or 3/4 or 1 and 7/32 or 2 1/32 inch tile. This is a highlight. It says some surface metal raceway designs are called pancake raceways because their flat cross-sectional resembles pancakes. Their primary use is to extend power, lighting, telephone, or other signal wire across a floor to locations away from the wall of a room without embedding them under the floor. So we don't want them to be a tripping hazard. So this is a pancake raceway. It's kind of beveled on a 45 degree so that it's not a tripping hazard. If you're walking along, your foot is more likely to go over it than to get stuck on the edge. There are also surface metal raceways that house 2 or 3 different conductor raceways. These are called dual or triple channel raceways. You use them to place different circuits such as power and signal in the same raceway. So here's one that has a divider down the middle. You can put power on one side and signaling cable or communications cables on the other side. Number of types of conductors permitted to be installed and the capacity of a particular surface raceway must be calculated and matched with NEC requirements as discussed previously. For surface raceway installations with more than 3 conductors in each raceway, refer to NEC Table 310.15 C1. Adjustment factors for more than 3 current carrying conductors, that's 310.15 C1. 3.3.2 Multi-outlet assemblies. Manufacturers offer many types of multi-outlet surface raceways. Their function is to hold receptacles and other devices within the raceway. When surface raceways are used in this manner, the assembly is called a multi-outlet assembly. Multi-outlet assemblies are either wired in the field or come pre-wired from the factory. Multi-outlet assemblies are covered in NEC Article 380. So here's a multi-outlet assembly. It's a wireway that has receptacles already installed on it, or like they said, you can install them in the field. You can bring several different circuits. I wouldn't bring more than 3 circuits in one multi-outlet assembly. 3.3.3 Power poles, pole systems. Sometimes power and other electric circuits must be carried from overhead wiring system to devices that are not located near existing wall outlets or control circuits. For example, this type of wiring might be found in open office spaces where temporary dividers form cubicles. Poles are used to accomplish this. The poles usually come in lengths suitable for different ceiling heights. Figure 69 shows a typical pole base. So here's a power pole. And on one side they have 120 volt. On the other side they have the communications cables, data cables, and phones. Okay. 3.3.4 Underfloor systems. Underfloor raceway systems were developed to provide a practical means of bringing conductors for lighting, power, and signaling to cabinets and consoles. NEC Article 390 covers the installation of underfloor raceways. Underfloor raceways are available in 10-foot sections and widths of 4-inch and 8-inch. The These sections are made with inserts spaced every 24 inches. The inserts can be removed for outlet installation. Inserts must be installed so they are flush with the finished grade of the floor. The removal of abandoned or discontinued outlets and conductors is explained in NEC section 390.57, discontinued outlets. Junction boxes are used to join sections of underfloor raceways. Conduit is also used with underfloor raceways by using a raceway to conduit connector. A typical underfloor raceway duct with fittings is shown in figure 70. So this is an underfloor duct. And you can go to an X or a T, and you can go in different directions, come up the wall. But they have junction boxes that are on the floor. They're surface mounted, or they're flush with the concrete. The concrete can come all the way up to the top here. Wiring method for lighting and power between cabinets and raceway junctions may include the following: conduit, underfloor raceways, wall elbows, or cabinet connectors. 3.3.5 Cellular metal floor raceways. As defined in Article 100, a cellular metal floor raceway is a type of floor construction designed for use in steel frame buildings. In these buildings, the members supporting the floor between the beams consists of sheet metal or steel rolled into shapes. NEC Article 374 covers the installation of cellular metal floor raceways. These shapes are combined to form cells or closed passageways which extend across the building. The cells are of various shapes and sizes depending upon the requirements, required structural strength. The cells of this type of floor construction form the raceways as shown. So they actually have holes in these steel raceway. They'll leave areas for you to run your electrical conduits and conductors. They're cells, cellular metal raceway. So these two cells are going in one direction, and this cell is shown 90 degrees to it, or perpendicular to them. Connections to the cells are made using headers that extend across the cells. A header connects only to the cells being used as raceways for conductors. A junction box or access fitting is necessary at each joint where a header connects to a cell. 2 or 3 separate headers connecting to different sets of cells may be used for different systems. For example, light and power, signaling systems, public telephones would each have a separate header. A special elbow fitting is used to extend the header up to the distribution equipment on a wall or column. 3.3.6 Cellular concrete floor raceways. The term precast cellular concrete floor refers to a type of floor used in steel frame, concrete frame, and wall bearing construction. In this type of system, the floor members are precast with hollow voids that form smooth, round cells. The cells form raceways which can be adapted using fittings for use as underfloor raceways. I was hoping they showed a picture of it. A precast cellular concrete floor is fire resistant and requires no further fireproofing. Precast reinforced concrete floor members form the structural floor and are supported by beams or bearing walls. Connections to the cells are made with headers that are secured to the precast concrete floor. Article 372 covers the installation of cellular concrete floor raceways. 3.3.7 Duct systems. In the common vocabulary of the electrical trade, a duct is a single enclosed raceway or runway through which conductors or cables can be led. However, underground duct systems also include manholes, transformer vaults, and risers. There are several reasons for running power lines underground rather than overhead, including in some situations, an overhead high voltage line would be dangerous, or the space may not be adequate. For aesthetic reasons, architectural plans may require buried lines throughout a subdivision or planned community. Tunnels may already exist or be planned for carrying steam or water lines. An underground construction duct system provides a safe passageway for power lines, communication cables, or both. A duct consists of conduit or an approved duct system, such as HDPE, high-density polyethylene, placed in a trench and covered with earth or concrete. The minimum depth at which the duct will be placed is determined using NEC Table 300.5A, the burial depths table. Underground cables may be buried directly into the ground or run through tunnels or raceways, including conduit and recognized ducts. Encasing the duct in concrete or other material provides mechanical strength and helps dissipate heat. Figure 72 shows a duct bank in place and ready for backfill. In this case, it will be covered in concrete. So they've made this duct bank, and notice that they always leave space between the pipes because they want the concrete to get between the pipes to give them adequate cover and mechanical strength. So all of these are spaced. OSHA defines a manhole as a confined space. There are certain OSHA requirements, guidelines that must be met to enter a manhole. For example, only qualified workers may enter a manhole, and another worker must be in the area outside the manhole. Manholes are set at intervals at an underground duct run. Figure 73 shows a manhole with several conductors already pulled through the conduits. There are the conduits in the duct bank, and it comes to the side of the manhole. The manhole is put into place, and then they pour the concrete. You can see how the concrete ran all the way up to the form. Manholes provide access through throats, sometimes called chimneys. At ground level or street surface level, a manhole cover closes off the manhole tightly. A duct line may consist of a single conduit or several, each carrying a cable length from one manhole to the next. Manholes provide room for conductor installation and maintenance. Workers enter a manhole from above. In a two-way manhole, cables enter and leave in only two directions. There are also three-way and four-way manholes. Often manholes are located at intersections of two streets. They can be used for cables leaving in four directions. Manholes are usually constructed of brick or concrete. Their design must provide room for drainage and for workers to move around inside of them. A similar opening known as a handhole is sometimes provided for splicing on lateral two-way duct lines, but they're smaller. They're usually about 2 feet by 3 feet. You can get your hands inside of them, but you can't get inside of it. So it's called a handhole. Transformer vaults house power transformers, voltage regulators, network protectors, meters, and circuit breakers. A cable may end at a transformer vault. Other cables end at a customer's substation or terminate as risers that connect with overhead lines. Underground duct lines can be made of fiber, vitrified tile, rigid metal, and non-metallic conduit, or poured concrete. The inside diameter of the ducting for a specific job is determined by the size of the cable that will be drawn into the duct. Inside diameters of 2-inch to 6-inch are available for most type of ducting. Rigid non-metallic conduit may be made of PVC or polyethylene or styrene. Because this type of conduit is available in longer lengths, fewer couplings are needed than with other types of ducting. PVC is popular because it's easy to install, requires less labor than other types of conduit, and is low in cost. Monolithic concrete duct is poured at the job site. Multiple duct lines can be formed using rubber tubing, cores on spacers. The cores may be removed after the concrete is set. Die casting steel tubes or die containing steel tubes known as a boat can also be used to form ducts. It's pulled slowly through the trench on a track as concrete is poured from the top. Poured concrete ducting made by either method is relatively expensive, but offers the advantage of creating a clean duct interior with no residue that can decay. The rubber core method is especially useful for curving or tubing part of a duct system. One of the most popular duct types is the cable-in duct. This type of duct comes from the manufacturer with cables already installed. Duct comes in a reel and can be laid in a trench with ease. Installed cables can be withdrawn in the future if necessary. This type of duct, because of the form in which it comes, reduces the need for fittings and couplings. It is most frequently used for street lighting systems. So they might have 1,000-foot reel of this stuff, and they can just peel off what they need, and they can even have it bored underground, bring it to a manhole, and they're good to go. Section 3.0.0 review. I'll let you all look at this and answer the questions. All right. I'll see you on the next page.